As we mentioned earlier, a MAC address for a network device is embedded on that device at the factory level, but IP addresses, on the other hand, are assigned manually or by software. Now, we've already mentioned before that an address can be dynamic, which means that it is assigned by a server each time it connects to the network, so it may not be the same address every time. Or an address can be static, which means that address is permanently assigned to that device. Now, for dynamic IP addresses, we use, or a server will use, DHCP, which is Dynamic Host Configuration Protocol, to give an IP address to a device when it first attempts to initiate a connection on the network. And it requests that IP address, or then the server assigns it using DHCP. Now, a computer or any other device that requests an address from a DHCP server is called the client, so it's a DHCP client. So you see how we use the server and client terms once again. And most times what we are using for when we are putting out those addresses is that we are giving that client not that IP address permanently, but on a lease value. So sometimes you may see that you lose connection in a domain network. It's because your device has removed that lease and you need to reestablish connection to the network one more time to request another lease for an IP address. Now, in a network, an IP address has either 32 bits or 128 bits. Now, when the internet and the TCP/IP were first invented many years ago, it seemed like our 32-bit addresses, we would have so many of them we would never have to worry about running out. Well, and we use that standard called IPv4, or Internet Protocol version 4. And this created about 4 billion IP addresses. Well, as more and more people got on the internet and more devices got on the internet, well, we ran out of those IPv4 addresses, and we've now had to realize, because of that shortage of 32-bit IP addresses, we need to look at expanding that using IPv6, or Internet Protocol version 6, which uses an IP address with 128 bits. Now, currently on the internet, we see a mix of 32-bit and 128-bit IP addresses, so we're using IPv4 and IPv6. And the governing body that's responsible for keeping track of those assigned IP addresses is INA, or IANA, which is the Internet Assigned Numbers Authority. So IP addresses leased from INA today, because we've ran out of those 32-bit IPv4 addresses, are now all 128-bit IPv6 addresses. Well, that's good information, but how are those addresses used? Well, a 32-bit IP address is organized into 4 groups, each of which are 8 bits. And these are represented as 4 decimal numbers separated by periods, such as the one listed out here, 72.56.105.12. Usually you will say dot and not period. Now, of these, the largest possible 8-bit number is 1111111, or 8 ones, which is equal to 255 in our decimal notation. So the largest possible IP address in decimal is going to be 255.255.255.255. And if we were representing this in binary using each of those 4 groups of numbers, which is called an octet, we would have 4 groups of 8 ones. So just remember, each of those 4 numbers separated by a dot is called an octet for 8 bits. And you can have any numbers between 0 and 255, making a total of what I was saying earlier, about 4.3 billion IP addresses. Some IP addresses are reserved, so these numbers are approximations. That's why I say about 4.3 billion potential IP addresses. Now the first part of an IP address identifies its network and the last part identifies the host. So when data is routed over the internet, the network portion of the IP address is used to locate the correct network. Now after the data arrives at that local network, the host portion of the IP address is used to identify that one computer on the network that is to receive that data that was requested. And finally, the IP address of the host may be used to identify its MAC address so the data can travel on the host's LAN to that host. Now let's take a look at classes of IP addresses. Now even though this information is kind of old, we don't really use it much anymore, you'll still find it referenced. Now IPv4 addresses are divided into, or were divided into, three classes: Class A, Class B, and Class C. Now, IP addresses belong in each class according to the scheme outlined here in this chart. Now, when the IPv4 addresses were available from INA, a company would lease a certain class license from INA, and from this license would generate multiple IP addresses to be used in an organization. Now, you can see how those octets work here. In a Class A, you will have addresses that are anywhere from 1 dot to 126 dot. So that's an approximate number of networks that you can have, or licenses on that network, are 126. The total number of possible IP addresses in each of those networks is 16 million. Now on a Class B network, we use the range from 128 dot to 191.255 dot for our address range. And then you'll see that we skipped the 127, and there's a reason for that, but we won't go into that now. And then to identify a Class C network, you look at the IP addresses, and do they fall from the network octets of 192.0.0 dot to 223.255.255 dot. And you see we can have a total number of 254 addresses in each of the network. Now in a Class A license, you can see that that license is for a single octet, which is the network portion of the IP address in that license. Now the remaining octets can be used for host addresses or to identify various subnetworks in a much larger network. So if, an example, if a company is assigned 87 as its Class A license, then 87 is the network address and is used as the first octet for every host using this license. So you'd have 87.0.0.1, 87.0.0.3, and so forth. So in practice, a large network is divided into subnets. Because there are 3 octets that can be used for Class A host address, one Class A license can have approximately 254 hosts, or about 16 million of those IP addresses. Now Class B license leases the first 2 octets, as you see here, the 128.0, and these first 2 octets are used for the network portion, and the last 2 can be used for host addresses or for subnetting various networks. Class C license assigns 3 octets as the network address, with only 1 octet used as the host address. Now these can be only 254 hosts on a Class C network, as I said earlier, or its subnetworks. Now there are also a couple other classes that we're not really going to go over because they're not available for general use. That's Class D and Class E. In Class D, addresses begin with octets 224 through 239. You see it takes up right after the Class C. And Class E addresses begin with 240 through our last available one of 254, and those are reserved for various research purposes. As I said earlier, we don't use 127 as an IP address because this indicates your own computer, and we use that for loopback addressing. We don't use 0.0.0, and we do not use 255.255.255.255 because the 255 one is used for broadcast messaging by TCP/IP for background processes.